Oh, it's loading up now. All right, and we are live on Kappa League TV. So, what's going on, everybody? My name is Hilton Cole. I'm the director of Guide Right for the Dulles-Leesburg alumni chapter of Kappa Alpha Psi. Today, we're going to be doing something new and exciting for our Kappa League TV channel. We're going to be we're going to be trying something new. So there might be some nuances here while we get everything figured out. Today, we're going to be doing something. There we go. Let me go ahead and mute that. So that's embarrassing. So that's just one of the kinks that we're going to work out. This is a new series called Titan Talk, where we're going to do live interviews with our guests that choose to come on. The scope of this conversation is going to be talking to really interesting people in the field, or Titans, people that are masters of their careers, or people who have really interesting stories. And then just breaking down some of the stuff that they're doing in their careers, or some of the experience or the journeys that they've had in their lifetime, to young men that have not gotten that exposure. So I'm really happy to be here. I'm really excited for what we can do as part of this Titan Talk series. We hope that all of our audience, all of our young men that are watching this right now, that you get a lot out of this first session. And there's going to be many more Titan Talks with really cool people in the field to come. So for our very first guest of this installment of Titan Talk, I am privileged, I am happy to bring you Mr. Jericho McLeod. Jericho is a very close friend of mine. We had met when he and I were working at MicroStrategy, the company, together. And he gave me a run for my money in terms of teaching me about artificial intelligence, data science, machine learning, everything analytics, and a whole bunch of other cool technologies that are happening in tech. And we've maintained our relationship throughout the years. And I thought it would be really cool just to have him here, just to pick his brain on what data science is, what artificial intelligence is, and really breaking it down for our young men that are in the audience, or really any student that's out there in the audience, just so they can get an understanding of what are all these hot technology buzzwords, what do they all mean, what kind of careers can I actually do with them, and why today in 2021 that concepts like those are so important. And why are they on the tip of everybody's tongues when you talk about STEM and when you talk about different technology fields? So without further ado, let me let Mr. McLeod introduce himself. Jericho, floor is yours. Just tell us a little bit about yourself, man.
All right. Well, first, Hilton, thanks for having me. I'm happy to be here. And it's good to see you in person, I think, for the first time in quite a while, or at least digitally. So about me, as Hilton mentioned, I'm a data scientist. I didn't start out as a data scientist. I did an undergrad program in accounting and then worked in finance for close to a decade. I went back to school for an MBA to take things to the next level. And in that program was introduced to data mining. And that was kind of from the user level. And I got interested in what was technically happening behind the scenes on a lot of the models that I was using. So I started learning the more in-depth topics, how to program them. And then moved into a software company. That's where I met Hilton at MicroStrategy, and was very fortunate there. And they let me develop those skills further and start working directly with clients to do machine learning and data science work. And now I am a full-time data science consultant and a PhD student in data science.
Awesome, Jericho. We really do appreciate that. So it's been a privilege to know you throughout this entire time that we've known one another. Really happy to have you here. So tell us a little bit more about how you and I first met. Tell us about your day-to-day at MicroStrategy. You started as a financial analyst at a nonprofit. You came over through software, and we know that you're doing consulting for real, actually applying your skills to light. But tell us a little bit more about how you and I first met, your experience at MicroStrategy, what it taught you. Just give us a little bit of career perspective on what it's like working in corporate, because a lot of young men in the audience, they might not know what it's really like. So tell us about, how we met and our relationship, and why, making friends is so valuable at a company, any organization that you work for.
Sure. Yeah. So when I first hired on, within the first week, you had kind of been identified to me as a leader within our team. And we were on the same team in quality analytics. And, so I went through the corporate boot camp, the internal training we had that's a few weeks long, and then moved into some training with you directly. Where you took us through a rotation that was really based on what the department you and I worked in was designed to do at a larger scale, just as a quick introduction for all employees. So I got kind of a toe dip in the waters before I went whole in. And that was an interesting experience. And one of the things that I found was it's great to have a mentor, someone like you at a job, because there's a lot of weeds to get lost in the corporate world. You know, how to navigate the structure of a new company, where everything is. And I don't mean, physically where's the break room, although that can be important. But
Right.
there's a lot of different systems you have to deal with. Your email system and your accounting system, where you enter your hours, things like that. These were all things that just having somebody to help navigate was really important. The really key thing, though, is having somebody that knows other people already. Because every problem you encounter at work, there's somebody in the building that knows what to do with it. And finding that person can be a challenge. So when you find somebody that not only has the experience of the day-to-day life in the organization, but already has a network, that extends your network. And that's vital. To say nothing of the actual leadership and keeping our entire team focused on objectives, which was a lot of your day-to-day, and keeping us from thinking something was neat, spending a long time turning a molehill into a mountain.
Really do appreciate that perspective, man. So just tying it into what we do here at Kappa League, we have these things called the 7 phases of Kappa League. One is identity and purpose. Another one is training. It's really interesting that you bring that up because phase 4 of Kappa League is actually social, where we really emphasize to our students, the importance of networking and really breaking your shell and really getting to know new people and work in different environments with them, and how to compete with them, how to collaborate with them, how to make friends in that kind of sphere. So our challenge to all of our young students is just like you heard Mr. McLeod give his pitch on things were a little bit crazy, coming into a corporate organization, you didn't know the lay of the land. Well, that's actually going to be your life, when you go to college or if you enter a career field, whether it's corporate or whether you're going off and being an entrepreneur, is knowing how to, break the ice and knowing how to approach new people and make new friends. And that's how you're going to actually survive in any thing that you choose to do. So we really do appreciate that perspective, Jericho. Really important. So why don't we go ahead and jump into the meat and potatoes of the conversation? So we really want to, demystify to all of our students, everybody watching this, middle, high school students, some of their families, really trying to figure out this thing called data scientists. And you're a data scientist. I know that you're still getting your PhD. You definitely know a lot more than me. You definitely know a lot more than most people that would even, come on to YouTube. So for someone who doesn't know or doesn't understand what data science is or why it's valuable, explain to me like I'm a 10th grader, what it is you and your people in your field do in the data science career. Let's give us a
Sure.
little
So
perspective.
absolutely. Data science is very much an interdisciplinary field. So you take domain knowledge. So let's say you're going to do data science specifically on the electric industry. So you have to know something about how the electric industry works, what the different major components of the infrastructure are, how power goes from a power plant to someone's house, all the steps in between. The next thing that's pretty important there is knowing how to program in some language, or at least to use some tool that can do mathematics for you. And the last thing is knowledge of math and statistics. A lot of the math that we all took in high school and college that we thought we would never use again becomes relevant in fields like data science. So the field combines those three in a feedback-driven loop where you take information from stakeholders, people that have some problem they need solved, and then you take data that's related, and you build an understanding of the requirements from the stakeholder and what's in the data, and you do that through exploratory analysis, and then you work on modeling. So you build something, some program that aims to solve that problem, and then you try it. You try to figure out how well it's working, and then once you have those results, you take it back to the person who's asking you to solve a problem, and you ask for feedback. And that becomes the business requirement that feeds back into the first step, and you can repeat that as a loop to continue refining what you're working on.
Got it. So data scientist is somebody who has knowledge of industry, knowledge of programming, and then knowledge of mathematical skills. And then what they're doing is they're talking to whoever their business sponsors are, whoever their bosses is, or whoever is hiring you in order to come on to their company for a project or as an employee. And they're hiring you to solve a problem. So there's some problem that they have that they've been able to describe, through data. They're trying to achieve a certain outcome that, you could think around it. But if you can put it into equation, if you can put it into a term of, problems that you can solve, just like you solve math problems when you go to school, how you solve some of your projects that you're working on while you're in high school, and come to an outcome. That's essentially what data science is in a nutshell. Just using those equations just and mapping it back to the problem that's being solved, and then programming in order to put that equation into practice and to find the ideal outcome that's going to solve that problem for that industry or for that company. Am I in the ballpark, Jericho? I might have oversimplified it some.
No, that's perfectly okay. So yeah, the very, very short definition there is using programming and some knowledge of math and statistics and the business area you're working on, the problem space, as we like to call it, combining those three things and building something that delivers insight. So you want to extract some knowledge that was in that data that answers a question that solves some problem. So, if you want to know how many widgets we need to produce to meet demand next year, you build a model that estimates how many people want to buy that widget, and then another one that estimates what the costs of the parts are that you need, and you put those things together and you can give somebody a number.
So gotcha. So think of it like this, young man. So instead of using a Excel spreadsheet, instead of using a long division or any long complicated form of math, what you're doing is you're training a computer program in order to solve some of these really complicated problems with a whole bunch of big numbers and a lot of variables at play. You're really just using a computer program to kind of expedite that process and make it faster of arriving at whatever that answer is, and then making that recommendation back to the business on here's what you should do, or here's what's going on based on the trend that we're looking at. All right. So we talked a little bit about data scientists. What about artificial intelligence and machine learning? So we hear about these words every single day in our lives. We hear about, what Facebook is doing, what Netflix is doing, what Google is doing. The news kind of, oversimplifies it, and we really don't know what they're doing. They always say, oh, it's the algorithms that do this and that. So what is it that machine learning and artificial intelligence actually are? And what are some examples of companies that, maybe I just spoke, or some companies that we've talked about in the past that employ both AI and ML?
Sure. So machine learning is really just a computer program that can learn an equation or a group of equations.
Okay.
So if we put that in perspective, everybody's familiar at some point in school with the slope of a line. And that's an equation we often write as y equals m times x plus b.
Hopefully you guys remember that one from your school.
So if you're given a set of y's and x's and you want to know what the slope of that line is, the m variable that we just mentioned, or its intercept b, your machine learning algorithm would take the examples and it would just learn those parameters.
Okay.
So it doesn't have to be explicitly programmed with the full equation. And then what it can do is say, given a new x that you don't know the y for, it applies that equation that it learned to guess what the new y is. Okay. And that's really the heart of machine learning. We typically do it on slightly more complicated formulas, but that's the gist of it. And if you hear about things like Google's DeepMind, it's just a very complicated formula. At the end of the day, it's just a very large, it's called linear algebra formula. AI then extends on that. All it does is add action to the end of machine learning. So we can talk about a company that does this, one that I think everybody is familiar with. If I were to build a machine learning model that could identify things on the road, so it can identify cars, it can identify the speed it's moving at itself, stop signs, red lights, etc. That's a machine learning model. If I then give it the capability to take action based on what it sees or what it learns, now it's an AI. So when you think of a Tesla, the actual part of the programming that just decides what everything is machine learning. The self-driving part would be the AI.
Got it. Got it. So it's really a concept of, finding the right outcome or finding the right number. And then the AI and the ML, the way that they work together is defining what should come next and actually performing that action. Like, I guess with that, the example of Tesla, and we were talking about this earlier. For those that remember, Tesla, they're doing the things with the self-driving cars. Uber is doing the same thing, and how they train that model, and correct me if I'm wrong, Jericho, but how they train that model is they'll have a whole bunch of pictures that are taken of different objects, like, what's in the road, other cars, people, to train the model of what's okay to go through and what things that obstruct your path or that get in your way that needs the car to stop so that you don't hit a person or you don't go off the road, that you stay within the lines, that you don't hit another car, or taking the best action so that another car doesn't hit you, little things like that. And what the AI is doing is actually, okay, now that I know what to hit, what not to hit, what's okay, what's not okay, and training that over and over and over, now I know and can drive myself because I've been trained before by somebody who's a data scientist or somebody who has that programming knowledge of what's okay in the road to keep going forward and what things should I avoid. And then to make those adjustments accordingly. If I need to stop, if I need to slow down, if I need to go left or right, things like that. Is that kind of it?
Exactly. And so the way we
Okay.
think of it in the field, the
Mhm.
data that we would be looking at is the streams from the cameras on the Tesla and the other sensors that it has.
Okay.
So it really
Interesting.
every second of a video is just a collection of pictures, and that picture is just a collection of variables. And so those get examined by the numbers that make them up. And that's how
Okay.
we feed them through the model. Now for the Tesla, it is again slightly more complicated than the slope of a line. But generally speaking, what it's done is it learns a set of equations that represent driving.
Right.
And those can be hard to define by hand. So we use very complex models that we're not even very good at explaining to do it. It's a fascinating topic, but it's also a very hard one to explain in less than an hour.
Enough said. What about something that's a little bit easier? So DeepMind, even though the programming behind that is crazy, even somebody like you told me that you might struggle understanding what goes behind that. But in terms of winning the game of chess or winning the game of Chinese Go, just can you talk a little bit about how the AI is used to like win the game, you know, and like untrained model versus what it means to beat a chess champion or a Go champion?
So it's actually this is kind of an important concept in data science. It's a definition of what a result should look like. And if you think
Mm,
about chess, it's a very simple condition. The king has to be able to be taken in the next turn and have no way to prevent that action from occurring.
okay.
So it can't move out of the way or be blocked or take the threatening piece.
Goal of the game is to put the opponent's king in checkmate. Right.
In chess, I don't know about Go. I don't actually know the rules of the game.
And chess, yes, yes.
Yeah, but so chess looks like a pretty simple game, and when you look
Mhm.
at it, it's a board that's 8 by 8 squares, and there's a total of 32 pieces.
Mhm.
So it doesn't seem like there would be a huge problem in just working out every combination. But it
Right.
turns out there are a massive number of possible chess games that occur. Uh, so we might be all familiar with the number of Google that the company Google is kind of named after, and
Mhm.
it's a very large number. There are more combinations of chess games than a Google, so it's far more than you can ever actually calculate. So what we do is use a thing called a heuristic, which is a shortcut. So we don't have to learn every game; we just have to learn kind of general strategies. And so that's how these games have been how AIs have been written to play these games. They don't necessarily learn by looking at every
Interesting.
possible game. They just look at games that have been played,
Mhm.
historical data, and train on that.
Okay, so they've taken a lot of data from people who have actually won in their chess games, and they start this model. It's like you don't know how to win the game of chess, you don't know how to take the opponent's king, but you feed it this data. You feed it, different scenarios of people actually winning the game, and then the computer program is getting smarter and smarter. to the point where it can make its own moves and it can find the best, I guess, sequence or combination of chess moves, like moving my knight here, moving my bishop here, in order to win the game. Is that a fair
Yeah.
explanation?
And so to add on to that, there are some additional and slightly more advanced topics that get put into this group. One of them is reinforcement learning.
Mhm.
So after the computer makes a move, you can have a human sitting there watching the game that tells it that was a good move or that was a bad move. And that helps it learn even more from direct human feedback. And other
Okay.
ones are similar, but you can also let an AI play against another copy of itself. So you can have
Interesting.
real games occurring that are just between the AI, and it can learn from outcomes of that because it may be trying one thing on one side and a different thing on the other, and learn from the outcome.
Okay. And then the best model wins. Whoever can win the most games or whoever can take the opponent's king faster. Would you assume that that's the better model?
In this case, I actually wouldn't differentiate the two. I would
Hmm.
spawn two new ones every time and then update the concept that's being learned here. So if we think back to the slope equation, we would
Hmm.
be weighting the M and the B and how much we move where we think the real answer is with a series of weights.
Interesting.
So the chess games, you would be updating the weights based on what they learned each iteration, but really you just have one core network or neural network that's playing these games. So you would
Mm.
just spawn a new one and keep playing it against itself as smart as it can be. And at the end, you still really have one copy. It's just a lot better than it was before you started.
Interesting. So one last question on this topic, because I want to try to tie it into something students do every day. We see the rise of gaming. We see your Fortnites, you see your PUBGs. You see all of these different games. There was a game I was telling you about back when we worked together. It was I think it was either Horizon Zero Dawn, if it was Final Fantasy or something like that. So tell us a little bit about how AI works in those games to try and come and kill me, the player.
So I'm not as well informed on
Mm,
game AI, but I can tell you that it is called an AI because it takes action.
mhm.
Just like we were talking about for the Tesla, the thing that extends the machine learning into AI is the action that it takes.
Right.
AIs in games tend to be more rule based, so they don't learn necessarily from actions that occur in the game.
Mhm.
They have a direct set of rules that are written for them that are programmed in. So if
Ah,
you do A, they do B, and if you do
okay.
B, they do C. So they
Okay.
have some strategy. Now, some games program them in fun ways where if you do a particular type of thing a lot,
Mhm.
the AI will do a different action. They also
Got
tend
you.
to adjust the parameters based on the difficulty. It's
Mhm.
not fun if the AI doesn't change. If you go to easy to hard on a game, you
Right.
don't want it just to have more hit points and take longer to kill the bad guy.
Right.
You want them to actually be a more intelligent bad guy. So they do things like raise how far away the bad guys will become aware of you, and
Mhm.
when they'll start taking cover. And that's what makes them seem more interactive at higher difficulty levels.
That's really interesting
So
because a lot of games that I play, when I put it on medium or if I put it on hard or the secret difficulty setting that you have to unlock, I feel like when I move this way or when I hit this action button, if I do it the first time, I'm able to hit the boss or whoever I'm fighting. If I do it a second time, it knows to counter me. It knows to block or it knows to get out of the way. So that's what led me to think there's like, man, there's got to be some kind of AI in these games where it's actually there might be some like rules where it's saying, counter or like roll out of the way or use this move when I use that move. But there is a part of me that also thinks it's actually reading what buttons I'm pressing and like what attacks that I'm throwing out. And then it's learning like how to counter me based on like my specific play style.
I think it's important to remember that the people that program games are usually gamers themselves.
Mm.
And I don't think they want to be unfair. But if you think about what you just said, where let's say, you do one attack and it takes it, and then you
Yeah.
do the same attack again and it blocks. So you
Right.
switch to another attack and it gets hit, but then you repeat that one and it blocks. So you go back to the first one and it still blocks that. So let's say you try a new third attack now and that one gets through.
Right.
But then you repeat it and it gets blocked. So all we really have to do to
Ah,
program this complex scenario is say, block the last two types of attack when they come in.
okay. So that
And
makes
so
sense here. So
now
like you
it's
have to
going to keep
cycle through your
changing.
attacks. Got
Yeah.
you. So if you have like 5 possible attacks, or 5 spells or 5, abilities or whatever, you can't use the same one twice in a row. And really you can't use 2 out of your 5, X amount of times in a row. You have to keep like switching it up in order to beat the boss. Otherwise, you're not going to beat it.
Or
It
do what
leaves that
works.
loophole open so that you can actually beat the game.
And there might be places where you get tripped up. Something doesn't
Mhm.
start blocking a certain type of attack after the first one. And
Interesting.
that's part of the fun of gaming, right? Figuring those things out about each encounter. When you come up on a new robot in Horizon Zero Dawn and you don't know how to deal with it, learning that strategy is what makes the game entertaining. So the better those AIs are, the better the entertainment value.
Got you. Got you. So that was a long conversation. We really do appreciate you. Hopefully, young man, a little bit more, using the game analogy, using the Tesla analogy of what machine learning and artificial intelligence is. We challenge you to go and check out, Tesla. We challenge you to go out and see like Netflix and how they learn from your likes and gives you different recommendations, or Pandora. Check out video games, etc., and do some of your research on your own. I wanted to kind of shift the topic, and it was something a little bit less technical. So just tell us a little bit about how you even got into this field and what made you stick with it for so long. I imagine you have to have some kind of discipline to do what you do. It's just not something you just like pick up, or you don't just roll out of bed when you're in high school and say, I want to be a data scientist.
No, I do wish I had done that when I was picking my major. It would have saved me a lot of time.
Right.
But I did come into this field sideways. I started
Mhm.
in the financial side of things. And during the MBA, I took a class with a very gifted professor named Palab Sanyal at George Mason University. And in this class, we were using software. So it's just a program you download. It was called RapidMiner. You download it and you can, if you think of like PowerPoint, you put an object in PowerPoint, you put another picture in it, and you can draw a line between them. Except this was doing that where you would drag in your data and you would drag in a model and you would connect the two and it would operate. It would perform data mining for you and you didn't have to code it. And that's what exposed me to what models could do and how they could be used. And it got me hooked. I was fascinated by the fact that you could use, this data to predict that outcome. Very interesting things to me.
And how old were you? I hate to cut you off. How old were you when you actually, started playing around with it? When you, were playing in PowerPoint, you stumbled upon that.
Oh, that wasn't in Power. That was in RapidMiner. Just to be clear, if anybody wants to go seek it out. I guess that would have been about 6-7 years ago. So I was in my late 20s.
Late 20s. Okay.
Yeah, but I had been doing what I could with analysis. I had the curiosity that goes well into data science well before that. I just didn't have the tools or the knowledge. No one had one of these talks available for me to learn that was the field I should study.
And that's why we're doing this now, young man. That's why we're doing this now. We're glad that Mr. McLeod, we're glad that Jericho was able to come in here, and very successful man, beautiful family, just got a new house, enjoying his career and his time in data science. But listen to what he just said. He's only 7 years new. He started 7 years ago. Imagine where he would be as successful as he is now if he would have started when he was your age in high school. So I guess that gets into the incentive portion. If I want to be a data scientist, if I want to do anything around like artificial intelligence or machine learning for a career, what kind of jobs can I get, and how much do they actually pay?
So they can actually pay.
You don't have to give us your salary.
No, I don't actually mind talking about it. I see a lot of people come straight out of college in this area, and they make between 80,000 and 100,000 a year.
Ooh, out of college?
Yeah.
Young man, write that down. $80,000 to $100,000 immediately, day one out of college.
Yep, and that's with just a bachelor's. So with a master's, or a few internships under your belt to go along with that, when you get to mid-level, you're looking more at like the 100 to 150K range. And then upper level, which is more like 10 years in or so, or with advanced degrees. I'm not in this range. but I see people getting job offers in the 180 to 240,000 range.
Oh,
And it can depend on your
money.
employer at that range, but
Mhm.
it competes with medical doctors in about the same amount of time.
Okay, so data scientists, the popularity and the demand for them is starting to rival doctors. That's what you just told me. And
In
we're talking
select
about some.
areas. You're not
Wow.
going to find a data science job in Mobile, Alabama that's going to pay you 240,000 a year. But in this area, there are positions like that.
Shout out Mobile,
Especially
Alabama Capital League chapter.
that is where I went to college. I went to the University of South Alabama for my Bachelor of Accounting. So I wasn't just throwing Alabama under the bus. That's where I finished one degree and started
Oh,
the
they're
job
gonna
hunt.
have fun with this one. But yes, it varies based on where you live and the kind of companies that hire you and the opportunities, that tend to be concentrated around the cities and where technology or forward-looking Fortune 500 companies are, in order to get those kind of opportunities.
Exactly.
Okay.
So I think for data science along the East Coast, you have the area really from DC to Boston.
Mhm.
Almost anything in that stretch is going to fall close to this range. And then you have the West Coast. So you have San Francisco, the Bay Area, and then north of there, Portland and Seattle. Those areas will pay really well. Some
Mhm.
areas in Central Texas, in Atlanta. I wouldn't expect, smaller cities to have as many data science opportunities. As far as the jobs, though, which is the other side of the question you asked,
Mhm.
so data science is a job title, but there are very related fields. The most common ones that I see are things like statistician, machine learning engineer, software
Mhm.
developer, and I would say research scientist, although that one you don't go into that one for the money. You go into that because you're curious and you like doing new
Mhm.
research. I
Interesting.
have a bit of
Interesting.
exposure there now because of the PhD program, and I'm doing similar work for my research that a research scientist would do.
Okay.
And it's fascinating if that's what you like, but you're never going to buy, a convertible uh, Audi on research scientist salary.
Interesting. So let me also ask you this, because we have some students that they're prodigies at math, or they have a genuine interest in technology, but you might have somebody who has an interest in technology, but they're not necessarily technical, but they still want a piece of the action. And we see this with a lot of technology organizations where it's literally might be 50-50. One piece is technical and then other people are non-technical. So in your field, if I'm not good at math, or if I don't have the technical discipline in order to stick with it, in my college studies or as I'm doing my own research, how do I still get a piece of the action?
Well, I don't think I have any of those skills, and here I am. So now, to be fair, I think it requires a mix, right?
Mhm.
So on the team that I work with day to day, there are guys that know how to connect servers and spin up Docker containers and do all these magical things that make the tools that I use work. And then there's me, who goes in and does a lot of the mathematics and modeling and statistical analysis that those guys don't know. And we're all data scientists. So there is a mixture. So you can go in either direction. But I would say if you have a strong love for mathematics
Mhm.
and you're always curious about things, how they work, why they work, this is a good field because you'll never stop learning. Every new project that I work on, I have to learn something to get it done. It's never just repeating the same thing over and over again.
Okay. Really cool. Really cool. So let's say if I'm watching this, I'm in middle school or I'm in high school, and if I want to get started now, I want to kind of just dip my toes. I just want to Google, I want to YouTube, I just want to like just research about, everything that we talked about today, from data science to artificial learning to some of the other topics that we touched on. What should I do? How should I get started?
I can point you directly to the Coursera course that taught me Python programming.
Oh,
It is a significant part of the reason that I am where I am today. Uh, and so that course was taught by Dr. Charles Severance, who
hmm,
teaches computer science, I believe computer science. He teaches programming of some kind at the University of Michigan.
okay.
Brilliant guy, but he really believes in sharing knowledge. He thinks everybody should be able to pick up and learn programming if they want. And
Got
Python is the
you.
most popular language in data science right now.
Mr. McLeod,
So
please say that one more time.
Python
Loud,
is
loud and clear.
Python is the most popular language in data science.
You heard it here, folks, on Titan Talk. I'm sorry, please
It's not new
continue.
to me. It's not the first time that's been said. There was some competition with R, and R is winning out in statistics when you want just the statistics side. But for the more generalized, Python is the way to go because it can handle more of the surrounding parts of data science than just the statistics.
Gotcha.
But back to the Python and the things to learn. So he has a free course available called Python for Everybody. You can Google those words and you'll find his free material. He put all the videos online and the book, and the software you need to use it is free to download. So that's a great source. That's how I got started. The other thing that you can do while you're still in school, focus heavily on math. And don't do it to learn the equation y equals mx plus b. The equation's not all that useful. What that equation means is useful. So knowing that, y is where you are on one axis and x is where you are on the other axis, and m is the relationship between them, and b is where you cross the axis. Those intuitions are what matter. So when you take math, try to understand, what's happening with these numbers, what they represent in the real world, because that's where they actually have value. Just knowing a formula doesn't help me at all. I need to understand, why that formula exists and why it's useful. And that starts while you're in school. I wish I had taken many more math classes before the PhD program than I had. So if I could go back and change something, that would be number one on the list, more math earlier. And not just to punish myself, because it's so useful. That's really the driver of everything computing, as much as we don't like to acknowledge it when we're actually programming.
That's the really cool thing. You said two really interesting things. Number one is the fact that we live in the era of self-study, where if you're not senior, if you're not adept at any particular topic, there's resources online, through Google or YouTube, or you had mentioned Coursera, where you can specifically learn more about Python, about R, about other programming languages, about SQL, which is important anytime that you're working with data. It's really cool how you can just like go on. Some of the courses are free, some are, you got to pay for, but they're much, they're accessible. You got $20 courses, $100 courses for what you're learning. You're definitely getting a good bang for your buck. So, the message I really want to emphasize that you had just said is that, like I said, we're living in the age of self-study where all of that information is out there. Just 20 years back when I guess the internet wasn't as powerful as it is now, where, there weren't a whole bunch of like fun people like, you and me, really demystifying data science and like how to get started. You'd have to like go through a whole bunch of books or go to like university in order to learn it. So that's my biggest message to you guys, young man. He's like, you guys are living in the age of opportunity where you can right now in middle and high school take advantage of that content that's out there. Mr. McLeod had mentioned Coursera, where you can start learning about Python, start learning about some of the topics that we discussed today. And then number two is, really being solid about math, because number one is like he had mentioned, really being solid about your fundamentals and the equations. But think about all of those word problems that you get stumped on when you're in 11th or 12th grade. They give you those problems not to intentionally trip you up or just to confuse you. It's really about contextualizing, a real life problem and trying to encourage you to come to some kind of outcome using numbers and applying those variables that you have to play with and the answer that you have to come to. That those are the different options that you have in life. Do I go with choice A or choice B, or what kind of option is within is acceptable? Is it above 100 or below 100? What kind of limits are we working with here? If I'm an athlete, if I can only take 12 shots a game, if my coach has me on a shot limit of 12 shots, what are the best shots that I could take? And they actually have programs that tell you on the floor based on previous shots that you have taken, where your best shot is, whether you're a 3-point shooter, whether you inside or whatever. So it's nothing just another math. It's really about learning that application, like Mr. McLeod has said. Jericho, you got anything else?
Yeah, I'll fishtail on that a bit and or coattail on that. You mentioned word problems, and that's such a good thing to bring up, because because that is understanding, from a conversation, or in this case, from a paragraph on a test or a book problem, how to formulate a problem. And that is the day-to-day of what data science is like. We talk to people and we try to get enough information to formulate the problem.
Gotcha.
And sometimes they don't even know what problem they want to ask us to solve. So it's a back and forth conversation to get enough points that we decide it is a solvable problem. And that is a very important skill. So I just wanted to emphasize the point made there.
Solid. So we really do appreciate that, man. We're learning a lot during this interview. If you're watching this either live or recorded, really hope that our audience is learning a lot. So I wanted to move on. So in terms of other careers, because one thing that we like to do in Capital League is, give our audience a lot of exposure to different career options. We've talked a lot about like artificial intelligence and what you can do with data science, how well it pays, what kind of jobs that you can actually get. But if you weren't doing if you weren't doing what you're doing right now, what other careers in STEM would you be doing today that they should also be thinking about?
So I would probably end up doing something similar that just has a very different name. So as much as it doesn't sound like it, the data science research that I do is the exact same thing as studying physics and then applying it to sociology.
Interesting.
Yeah, which it doesn't sound at all like those would cross over. But if you think about what physics really is, it's the modeling and study of the natural world. And you do that with math problems. And then you create a model that represents what you observe. So when you do that for something like a sociological problem, so like, how much people are going to school in different areas of the country versus what the incomes in those areas become later, that's a data science problem. But it can be solved with a physics model on social data. So I would try to do something that uses a lot of math, similar to what I do now, but it would be more research scientist oriented. I think the other common thing that comes out of people that work in data science really is the machine learning side. A lot of people like that because it sounds cool. And then when you learn more about it, it actually is pretty cool. There's a lot of fascinating stuff happening in that realm. And that's a type of math that I am not as enthusiastic about. I know it, I'm very familiar with it, and I can do it. It's just not where I like to research. Whereas I think everybody else, if you asked anybody else this question, that would be their first answer, where they would want to go into machine learning engineering or machine learning of some type. And that is huge and growing. I see tons of jobs. I think there are more jobs for that than there are people capable of doing the work.
Gotcha. Interesting. So putting the AI aside, putting some of the data scientist bits aside, I remember back when we were working in MicroStrategy, you had this interesting hobby, and you had a lot of action figures. I thought it was kind of corny at first, but then you told me how you made them, and I was like, whoa, that's freaking sweet. You know what I mean? So tell us about how you built your figures using 3D printing. Another cool technology that I wanted to introduce today while we're doing this Titan talk. So tell us about what 3D printing is, why 3D printing is so cool, and where that industry is going in terms of, I've seen them build houses with it. I heard not too long ago they had built a heart with 3D printing. I'm not sure if it was like real or not, but what kind of careers might exist in the future around 3D printing that kids could be thinking about now?
Sure. Yeah. So 3D printing, it really starts with a model of a digital representation of something on your computer.
Okay.
So just like in a video game, you have a character and that's some shape that you can look at and you can spin it around and look at it from different angles in 3D on your computer. That's what these models start as. And then there is software that turns them into a set of instructions. So it goes, layer by layer, stepping up the shape and figures out what pathway to take if you were going to print it. Or for some types of printers, it cures resin with a light or a laser. It gives them a different set of instructions, but both types create a set of machine instructions that say when to step up and where to put material in place. And then you have the actual 3D printer. And it's just a machine that can take those instructions and put material into the correct place that will adhere to more material so that you can layer by layer build up some object. So it's kind of like if you print a single page of a footprint, and then you print another page and lay it on top of that, and the ink is just, slightly above the footprint, and you do a stack of layers like that, representing a cross section of a person at each layer, and you take away all the paper, the ink that's left would be an action figure.
Interesting.
Layer by layer. So it prints just like a regular printer, one layer at a time. It just keeps them in a stack, and the material adheres. So it's a $14 billion industry now.
14 billion.
14 billion.
That's a lot.
So that's the consumer side. That's not counting R&D into new things. Like you mentioned, medical printing.
Right.
So printing, cells that can actually grow on a lattice framework, and using those in surgery in the future. That's part of the future of this industry. And as we all know, the medical industry is not poor. So there's definitely going to be job opportunities.
We don't need to go there today, Mr. McLeod.
It might make you poor.
Oh.
No, but I mean, it is a well-paid industry. There's a lot of funding and research in medical sciences, and that is capturing part of 3D printing. But there's also the material side. So there's research into the materials. There's research into constructing affordable housing with 3D printers. Now they're slightly larger than the ones I print action figures with, but they can print cement structures now. I think job-wise, there's a couple of interesting careers there. I mean, you have to have people that design those 3D models, and that's a talent unto itself. I can do minor modifications, but I have designed almost nothing from the ground up because it's hard. And that's not where I've spent time developing skills. And then you have more generalized, software developers, programmers that write the programs that let you do those 3D shapes, and also the ones that convert machine instructions. And then another set that write the code that runs the 3D printers. So there's a lot of programming that goes into these. And then there's engineering, more mechanical engineering types. These are the people that design the materials for 3D printers, or even if they work in a completely unrelated field, they're the people that use 3D printers to print prototypes. And that's really the origin of the industry, was rapid prototyping. Used to, you would design something and then you had to send it off to a factory that had to tool up their machines to print out,
to make
or to manufacture one of an object at huge cost. So it's driven down the prototyping costs for mechanical engineers and probably some other types that I'm not as familiar with. And I suppose actually there's also even electrical engineers that design the components in 3D printers. As for new directions, you already mentioned one that's pretty fascinating. I think more generically, we could say that small makers are going to be more empowered, people with new product ideas. So we're able to see more rapid evolution of small businesses because of 3D printers. We're seeing new products becoming possible or scalable because of 3D printing. And we're also going to see 3D printing in environments where logistics are a problem. And so what I mean by that, logistics is just getting stuff from point A to point B. If we really upset all the people that work in logistics by oversimplifying. But one example of 3D printing being used where logistics are a problem, on the International Space Station, they needed to do a repair and they didn't have a tool. So some people on the ground designed one and emailed a copy of the design file up to the space station, and they 3D printed the wrench they needed. So that's a case where something was designed on one planet and then printed in space. In the future, if we go back to the moon, or we build a Mars base, or even just remote places on Earth, that's a way to share physical objects where all you really have to bring with you is a small amount of material, and then you can use that to build whatever thing you happen to need instead of bringing all of the things you might need.
Got you. So it's really just a matter of, if you already have that model, which is really that 3D blueprint of what you want to make or what you need to make, all that you have to do is send the material, and the material can be in like crates or whatever easiest containers that you can ship it in, as well as the machine that's actually going to make it. And then you can make those machines, make whatever it is that you need, like supplies or housing or whatever, for Mars or for the moon or wherever that you want to go, instead of sending all of that equipment, ready made all at once. which I'm sure is a lot more
Yeah,
expensive, right?
exactly. And also just the idea of, let's say you bring 50 pounds of material,
Mhm.
you know that you're likely to need some tools, but you don't know what they are. Rather than bringing all of the possible tools at once, which would be
Mhm.
more than 50 pounds, you just bring enough material to probably make more than you'll end up needing. Uh, and then the actual shape that it's in doesn't matter. It lets you reduce the amount of stuff you bring with you.
Got you. That's some really cool stuff, man. In terms of affordable housing with 3D printing, I really think it's cool because you look at the housing crisis now, and there's not enough supply, and there's really kids don't understand this, but a lot of the raw materials that go into houses, aren't as easily available anymore. So what this means for you is that when you get to be my age, Jericho's age, it may be, if current trends pace out, really difficult to in the future buy a home in the United States. But with 3D printing, if you're able to reduce the cost of some of those materials and like get them into the machine and build different models for different housing units, it could be a more affordable and easier way in order to solve this housing problem that we're in right now and give people an affordable place to live. Now, it might not be a mansion that you can build with 3D printer. Correct me if I'm wrong, Mr. McLeod. You can't build mansions yet. You can build something really basic. But I think 3D printing really is going to be one of the cool technologies that is going to solve the affordable housing problem going forward. And then we talked about the medical aspect too. Being able to print organs. If you have tissues or whatever the raw material that goes into the machine, they can actually print you a heart or print you a brain or print you a lung. Think about what that does for science. If you have failure in any one of those, or if you have to have surgery on any one of those, what does it mean to give yourself a new one? Now, brains might be a little bit more complicated. I'm not sure if they actually put the heart in a person, but that's where the technology is going. That's where the
Yeah.
trends are. So in terms of other trends, I know you keep your ears to the ground a lot. I know we're running out of time, but just tell us a little bit about some other cutting edge technology trends that kids, middle school, high school, maybe early college should be taking a look at. What are you most encouraged about and excited about that Gen Z or, anybody lower, Gen Alpha, I guess that they're called, anybody still in high school and college, what trends should they be paying attention to right now, based on your opinion?
Well, I think it's probably important to build a good baseline understanding of some of the
Mhm.
stuff we've already talked about. So we were talking about machine learning, and neural networks are the big topic there. And it's somewhat important to at least understand what's going on in those conversations.
Mhm.
Even better if you want to go into it and research them. And the irony here is that neural networks aren't really a new thing. The core concept. So when you think of a neural network, let's draw this out. You have a bunch of dots, and they're connected by lines.
Mhm.
That's the very simple. And those dots are things called perceptrons. That's just the name they were given. Those were invented in 1958
Mhm.
by a brilliant guy named Frank Rosenblatt. They're not a new thing. And then I think sometime, 20, 30 years later, somebody said, hey, what if we put more than one of them together
Mhm.
and we can solve more problems? And then somebody else said, well, what if we do even more? And now we're at massive networks like Google DeepMind. But understanding how those work and the limitations is not going to go away.
Mhm.
So understanding, model validation and how accurate they can be, what fallacies can go into them, biases, those things are going to continue to be important, and they're going to be more and more important over time because the utilization of these things is going up. I don't think there's any way that this is going to start decreasing unless we just decide to do away with technology as a race. If the human race decides to give up computers, then probably won't be a good field to be in. Uh, but I think keeping an eye on these things and the safety of them will continue to be an important thing.
Got you. So those are some of the things to keep out for. Definitely want to keep your ears to the ground on what's happening with machine learning and how that field organically develops. Because think of it like this: if machine learning and if some of these technological trends are not in your industry, and say you work at the bank or work as a lawyer or work, even as a doctor, they will be in your industry at some point. So you definitely got to keep an eye on it, even if you're not, particularly steered towards STEM.
Those are all
So
three fields that currently have neural networks in place. So we
Uh-oh.
have a legal review AI at work. And I know in medicine, there are a number that identify like tumors on brain scans.
Mhm.
And what was the third field that you mentioned? So law, medicine, and
I said banking.
banking.
Yeah.
Oh yeah, financial bank. So in finance in general, there are a ton of models that are day trading.
Yes.
So these are all. So even the fields where it seems like the day-to-day employees aren't using these, machine learning's already crept in some form or fashion.
Right.
It's somewhere creeping in on the day-to-day stuff.
Interesting. So let's talk about the flip side of that. So what about technological trends that concern you today? I might make your answer a little bit biased, but we've heard a lot about Facebook in the news recently. We've heard about like Tesla and the accidents being generated by the self-driving cars. We've heard about kids with an addiction to social media, or different content that's now available online that weren't online earlier. Just talk to us about some of the technological trends that concern you today. you know
So you bring up an interesting one, the social media addiction and even ideology
Mhm.
influence. I'll put that on hold for just a moment and talk about one that comes out of social media as well that is of more concern to me personally, and that's
Mhm.
privacy. So I know it's
Mm.
something that we all hear about and probably are tired of hearing about, but it's not going away. And there's an important concept to realize that any website that you use that is completely free to you
Mhm.
exists to make money off of you. So you are the product.
Yeah.
When you go to a website and it has ads, that's pretty easy to see. The ads are what's supporting that revenue. But when you go to one and you don't see ads, or you see ads that get very specific about you,
Right.
then what they're really doing is using information they've learned about you. And they do that with data science. And this gets into the ethics of data science and machine learning. But they use knowledge about you to shape ads, and they can accumulate a massive amount of information. So you can look up how to see what information Facebook or Google has about you as an individual, and you
Mhm.
can read through it, and you can actually make corrections if you are so inclined, or you can ask them to delete it. Now, when you delete it, your ads become very unrelated to your interest, and it seems awful, but their purpose in doing this is to target these ads. But there's also been cases where this information has been sold or has been breached. And
Right.
when someone who has bad intentions knows the amount of information about you that some of these companies know, they can take action. And sometimes they can do serious harm to people. And as you develop this level of knowledge about a large number of people, then you can
Mhm.
start influencing behaviors at scale. So we saw this, and it may be a bit of a partisan thing, but we've seen national actors interfere with the governance of other countries through the
Mhm.
use of social media.
Yes.
The other side of this, so privacy was the thing that I wanted to bring up, but you had mentioned the social media addiction.
Mhm.
I do think that there's a question of the cost of social media on us as a society versus the benefit that it's brought. Because if we think about what we post on social media, we never post our regular moments where we're sitting on the couch eating Cheetos wearing gym shorts. We post the highlights of our life. So
Right.
then when you go scroll through social media, all you see are the highlights of other people's lives or the things
Right.
that they want to drag out in public. You're not seeing the day to day. And so if you're in your day to day moment or you're in a slump and all you see is everyone else at their best, it doesn't help you.
Correct.
And
Right.
I think there's been a lot of research into the behaviors associated with social media addiction to drive it, to drive engagement, which may seem unethical, and it may be unethical. I'm not here to pass judgment on the ethics of social media, but it's a risk, and we're starting to realize this, and maybe we'll start to take action on it as a society over the next few years.
Mm.
I do want to mention one more uh, concerning trend in technology,
Please.
and that one is the ecology. So
Ecology.
we may be encroaching on ecological disaster. Everybody's heard of global warming, climate change,
Mhm.
etc. But you can simplify it to things that make sense, right? So if we look at Bitcoin, which is a cryptocurrency we've all heard of.
Mm.
And it's made a lot of people a lot of money, which is great. I like seeing people raise it up. But there's a cost to Bitcoin. To mine one single coin today takes the same amount of electricity that the average US household consumes in 58 days. And in the US.
So in 1 month and a half, the power that I use at my house, assuming if I have a regular house, that's the energy that it takes to mine one coin. So think about like all your electronics, your appliances that are in the house, or the energy that you got running on in the background to mine one coin.
Yep. And that was for every Bitcoin that's been mined. And in the US, only 12% of our electricity is renewable right now. So that means you're basically, for every coin mined, you're running a household for almost 2 months. And 88% of that is adding to climate change. And then every time you buy and sell a Bitcoin, there is technology in use to make that happen, and that costs money. And we keep an eye on this even in data science, because we can build a model that will figure out what y equals mx plus b is. And we can do that in a way that's as simple and as concise as possible, as small of a program as possible, or we can do it very inefficiently and use more electricity than is actually needed. So we keep an eye on how optimized our data science models are, because we don't want to waste energy. And some of these things can take large amounts of energy. We often will run models that require months and months and months of an entire server running just that model. And that's a very common thing in this field. So it's something we're becoming more aware of and cognizant of when we're in the design phase. How much is this really going to cost, not just in terms of the computer that we have to buy and our power bill, but what's the long-term cost to society if we keep polluting?
It's really interesting. So it's like, I guess the conversation steered from, technology trends that concern you into climate change, which, in order to use technology requires, energy, each device that you use. We talked a little bit about Bitcoin. So, hey, if I go to your social media and I see Bitcoin on one and a post on climate change on the other, those are kind of, opposites of one another. So you got to think about your priorities. But, if I'm in high school, if I'm in college today, what are the things I should be doing to do my part in order to address climate change? Is it like using less? Is it, about voting this way or that way? Like, what do I actually do? I still want to have a planet by the time I'm, an adult.
I'm hesitant to give advice to an individual. No, it's fine. To an individual to say, this is what you need to do, because really the problems are businesses, their governments, their militaries that have massive scale. And now as an individual, you can be cognizant of things, but I'm doing this as an employee of a company, and we're deploying models for commercial and government clients that are very large. So we're doing things that have an impact on a very large amount of people and infrastructure. I'm not just doing it for myself. Now, all of my light bulbs are high efficient. My appliances are energy efficient appliances. And, I try to use good mileage vehicle. I have one right now that is almost zero emission. Things like that will in the long run matter. And I think we're seeing hybrids and electric vehicles take over, and that's not going to go away. But I think when you start to enter the workplace, to keep this mindset and to act on it where you have political power. So in the poll booth, when you cast election votes, and when you talk to other people, that's really where the influence is going to be shown that has the largest impact. And then once you're in the workforce and you're deploying these things, you have the decision of using something that takes 1/10 the energy but costs 1% more, and weighing these costs and deciding what you think is best for society and not just ourselves.
Interesting. So there might be like limited things I might be able to do individually, but like really campaigning my government, campaigning businesses, that I buy from or that I invest in to take the action. That's what's really going to solve the problem at scale. And of course, I'm sure there's something that we can do to, influence one another and to make smart choices ourselves. But I do get your point that until those businesses, until governments, really take this thing by the horns, we might be in for some rocky waters in terms of climate change. But I really just love, to end it on a positive note, how this young generation, they just totally get it. Like when you were in high school, I'm sure when I was in high school, the conversation was more so 50-50. One thing that does give me encouragement is that this generation, our Kappa Leaguers, everybody in Gen Z, and most people in Gen A that are coming up right now, this is just, accepted as a fact. So I'm really curious to see, what they're going to take from our conversation today and what they're seeing from the news and what information is available and coming up with some creative solutions. Speaking of creative solutions, this brings us to our last question. So I remember that you had told me when you and I had first met that you're from a small town in Mississippi. You were able to get out, you were able to explore the world and grasp a really bigger perspective, especially when it comes to like hot topics like race and identity politics. So in terms of all the challenges that we have today, we talked a little bit about yesterday in terms of having different perspectives in the room. What message do you have for youth, black or white, on the value of diversity and how your perspective on youth today can continue the progress to create a more like inclusive society? And how does technology play a role in that?
So I think it's super important to
Mhm.
have diversity in technology. We've seen the failings of not having diverse people contributing to technology. You can build in bias just in a machine learning model, just from something as simple as not having a diverse group of people that look different. We
Mhm.
saw this with Samsung. They produced some cameras and they were designed in Korea, where most people are, or in South Korea, where most people are Korean.
Right.
And they designed these cameras with a really cool new feature to identify faces and focus correctly on the faces. And
Mm.
then they shipped them worldwide. They got to America. People opened the box, tried to take a picture, and realized my camera won't find black faces. And this
Okay.
was a thing that actually happened. You can go look it up. It couldn't detect the face of a black person. And
Wow.
that's as simple as they just didn't test it on somebody who had darker skin while they were in the QA phase. And because they all looked the same, they didn't think about it. And so, I
Wow.
mean, that's an overblown example, but it shows where just having diversity in the workforce can cause you to not make a blundering mistake like that. And it's a super important thing to have people from different backgrounds because everybody brings a different perspective to the table and they all add something. So I'm at a job now in a field that's pretty well known for not having a lot of diversity, and we're actively trying to change that
Mm.
because we realize that that's a weakness on our part if we don't have a diverse group of people working together. So I'm on a diversity committee at work, which sounds weird because I'm a white guy in America, right? So I'm the majority, but it has to start with me if I'm the person who's there. So if people that look like me aren't demanding it, it's going to be slower progress. So we all have to contribute to it, whether we look like me or we look like you or anybody else. Wherever you end up, demand diversity. And
Gotcha.
inclusion, I think, builds on diversity. Inclusion is once you have everybody there, make sure they're all equally supported.
Mm.
So if you remember last year, there were some events, and I reached out to you just to make sure you were okay. And
George Floyd
that's
process.
inclusion.
Yep.
And I think that's vital. So we have people, from different religions, from different countries, from different ethnic backgrounds, supporting them and not excluding them from things based on who they are is vital to having diversity. And you can't have a diverse workforce if some of your people feel like they can't be their true self at work.
Right.
And I think that's something that this generation thinks of differently than prior generations did, especially where I'm from. I don't think we've mentioned this, but I grew up in Mississippi, and the general concept when I was in school is not the same as it is today in the business environment.
Hmm.
And that's something that I'm very lucky to have learned better than my grandparents were taught when they were kids. I count myself very fortunate to have a multiracial household and to have traveled to the places that I've been to. And I think the biggest feeling that I have for people that disagree with that mindset is just sadness. They don't know what they're missing because it's just a better world when we have people that are different and bring different things to the table and have different experiences. So I think keep driving for that, and wherever you end up, demand it.
Thank you so much, Jericho, for that perspective. Just adding on to that. I grew up right here in Northern Virginia, so I guess I was blessed to have a perspective where I went to South Lakes High School right here in Reston, Virginia, where, there was Black, there was white, there was Middle Eastern, there was Asian, there was Hispanic, there was white, there was Eastern, European, there's cultures from all over the place. So, there's a lot of places like Northern Virginia or like urban areas like the cities like New York or Los Angeles where that message is really being drilled through. And it's not so much that we don't see race, it's just we acknowledge each other's differences, we celebrate them, and then we come to find out that we can create an even stronger team than just creating a team of like Black people or creating a team of white people or so on and so forth. So I really do applaud, some of our parents, in the Black community, we might think it's weird, seeing a Black kid hang out with his white girlfriend or, white friends or whatever. But that's a sign of progress right there when you really think about it in hindsight. Or if you see a Black kid hanging out with a white family, going over their house, it's really nothing in some parts of the country. Other parts of the country is still a lot of work to go. I'm really proud of the progress that this generation has made. Certain progressive areas have made, just like right here in Northern Virginia, the schools that we have here. And to our Cap League program here in Dulles-Leesburg and the other Cap League programs all over the country, just like Mr. McLeod said, you want to make sure that you have a diverse team of people around you. Of course, you still want Black friends, you want people that identify with you or look like you, but really reach out and take time to learn about other people's cultures. Take time to invite other people that don't look like you onto their team, or if you get an invitation from them, go ahead and join their team, because you never know what kind of outcome that you can drive when two people that don't look like each other come together. Look at Jericho and I, Black and white, two completely walks of life, but we're able to do a really cool event like this. And back when we had worked together, we had a really successful relationship, and we both of us co-led. He gave me a lot of credit, but we co-led a really diverse and dynamic team that got a lot of stuff done. So I guess we can end it on that positive note. Jericho, we really do appreciate you taking time to speak to us today, speaking to our Cap Leaguers, speaking to all of our students. Really do appreciate all of our audience for tuning in to this first inaugural edition of Titan Talk on Cap League TV. Really do appreciate you. Stay tuned for our next episode where we're going to be interviewing Mr. Tony Wiley, the managing director of the Special Olympics and the former executive vice president of 4 different NFL franchises, doing public relationships for them. So really do appreciate you guys. Thank you so much for tuning in. Bye-bye, bye-bye, bye-bye. Thank you so much.
Take care, Hilton.